Okay, so today's focus is going to be on inscribed angles, and we're going to kind of talk about the difference between an inscribed angle and a central angle. So the one main thing that I hope you notice is that in this angle in the circle, an inscribed angle, the vertex is on the circle. So that's the first thing, is the vertex is on the circle. And if we were to fill in values here, if I told you this intercepted arc here was 50 degrees, this is the intercepted arc, the inscribed angle here is going to be 25. So the relationship is half of the intercepted arc is equal to the inscribed angle. So basically, if this is 50, this is going to be 25. If this is 100, then this is going to be 50. Okay, so that's kind of the basic concept there with an inscribed angle. Now, the other thing that we're going to take a look at today is the concept of an inscribed polygon. So let's look at this pie piece on our spinner. So inscribed polygon. So two things here. Notice in this first picture, I've got an inscribed triangle. Inscribed just simply means that the vertices of the polygon are on the circle. Now we're going to assume that this is a diameter, so that makes this intercepted arc 180. So the one thing I want you to notice is this inscribed angle here inside the semicircle is going to be 90 degrees because it's half of 180. So the main thing from this little section that I want you to write down is that an inscribed triangle inside a semicircle is a right triangle. Okay, so inscribed triangle inside a semicircle will always be a right triangle. So we've got a 90-degree angle. Now let's move over here to this other picture of the inscribed quadrilateral or polygon there. Here the main focus I want you just to kind of see is that the opposite angles, their relationship. So notice angle C intercepts arc BAD, and angle A intercepts angle BCD. So basically the opposite angles are going to intercept the whole circle. Well, we know that the whole circle is 360, so that means these two interior angles together have to add up to 180. So the thing we're going to write down here is that the opposite angles add up to 180 degrees. So if I were filling in, let's say angle C, let's say I told you that it's 95 degrees. Well, then angle A has to be 85 degrees. If I told you angle B is 105, then angle D has to be 75. So again, opposite angles, again, notice their intercepting points make it to where each of the angles is intercepting the whole circle. And that's how we're getting the 180 degrees there. Okay, so the other thing that I want to kind of go through with you here, again, this is just another picture demonstrating the difference here between the central angle, which they're the same, and then the inscribed angle, how it's half of the intercepted arc. I want to point out to you, sometimes we will have these problems where the angles intercept the same arc. So for example, let's say I told you that from here to here that this arc is, let's say, 80 degrees. Well, you will notice in this picture that this angle here intercepts that arc. That's an inscribed angle, so this would be 40 degrees. You will also notice that this angle here intercepts that same arc, so it's got to be 40 degrees. And the same is true with this angle, so it is also 40 degrees. So paying close attention to the arc that's being intercepted, again, even though these vertices are in different places, they're all three intercepting the same arc. So their angle measure is going to be the same in each of those cases. All right, let's take a look at an example here where we have a right triangle inscribed in the semicircle. It wants you to find the measures of angles A, B, and BCA. So take a minute, look at your spinner, see if you can solve for the different angles. Pause the video, and then we'll go through it here in just a second. Okay, so in this picture, we know that since this is inscribed, that this angle has to be a 90 degrees, so angle B is going to be 90. We know that angle C is inscribed angle, and it's intercepting the 120, so half of 120 makes this angle 60. And then we also know that given the picture, we also know that it's a 30, 60, 90 triangle, so this would have to be 30 degrees, which would make this intercepted arc 60, which would make sense. 120 plus 60 equals 180. This arc here would also have to be 180. All right, the last example that I want to take a look at, on this one, they're asking us to find the value of x. Again, we have an inscribed angle, 5x plus 4. We know that the intercepted arc is 208. So a couple ways you could think of this. First of all, we know that this angle has to be half of this angle, or of this arc. Well, if this arc's 208, that means that this angle has to be equal to 104. So probably the best way to do this would be to say that 5x plus 4 equals 104. Now the other thing you could do is you could say that 5x plus 4 times 2 equals 208. So that would be another way to write the equation. If I solve this and I subtract 4 from each side, I get 5x equals 100. And if I divide both sides by 5, in this case, I get x to be equal to 20.